Hello, everyone, and thank you so much for joining us. My name is Jonathan Raphael, and today we're going to talk about SkyTruth's newest product, Cerulean, that we launched publicly in November of 2023. We're excited to give you a tour of the interface and functionality that we've published. First off, a little about SkyTruth. We were founded in 2001 with the idea of using satellites to bring to the public's attention environmental issues that happen so far away that they are often invisible, even to those communities that primarily feel their effects. We want to serve as an international watchdog for all sorts of environmental concerns, both legal and illegal. For instance, shown here are some areas of our concern: mining, deforestation, overfishing. You may know Global Fishing Watch, which we previously launched in collaboration with Google and Oceana. Harmful algal blooms, oil and gas development, as well as flaring at those sites. And finally, oil pollution on the oceans, which is the topic that Cerulean was designed to tackle. Cerulean itself is an automated machine learning pipeline, which takes in imagery from Sentinel-1 satellites, like the one seen here, and produces a database of potential oil slicks on the ocean surface. Primarily, we find pollution from moving vessels and from fixed pieces of offshore oil and gas infrastructure. Both of these are chronic and staggering in their volume. For instance, this one event shown on the screen is estimated to be formed by 70,000 liters of oil. And the islands you see in the lower right corner are, in fact, a nature preserve. In special circumstances like this one, we can single out the culprit of a pollution event at the sharp end of the oil slick down on the left, and we are often able to use AIS to discover the identity of the vessel. Now, to tell us more and show you the actual interface is my colleague, Brendan Jarrell.
All right, so here we are in the Cerulean UI. Starting on the left-hand side of the map, you'll see a number of options designed to filter down the slicks you'll be viewing on the interactive map. Filters can be set for date range, slick size, and source type. You can also filter slicks using the Cerulean model's level of confidence in a detection. So if I were to raise this confidence level, I'll see fewer slicks, but the slicks are more likely to be true according to Cerulean's algorithm. And if I wanted to see every slick possible, I could lower this way down and see all the possible slicks our model has detected. Now, when you do that, a lot of the slicks will be what we call false positives, but you may catch some true slicks that the model wasn't sure about. We also offer map layers for marine protected areas and exclusive economic zones at the bottom here to add further context to the detections you're reviewing. Now that you've set your filters, let's zoom in and take a look at one of these Cerulean detections. Okay, so when I click on one, a few things are going to happen. First, the original Sentinel-1 scene will appear beneath the slick outline here. And then you can toggle on and off that slick outline using this button here. And you can also turn off all other slicks besides the one you currently have selected using this button in case the map is somewhat crowded. Now, when you've selected a slick, the left panel brings up more detailed information about the slick derived from our method and from the image that it was collected from. You can also display the direction of wind and current at the same time as the selected slick using these buttons here. And then you can click this button to generate a PDF report that captures details about the slick and puts it into a format that's easy to share with your colleagues. Now, Cerulean may be able to point out potential sources of the slick as well. And to identify vessels in particular, we match ship's automatic identification system broadcasts, otherwise known as AIS, to the slicks. Okay, so let's turn these on. Now, the arrows at the end of each track indicate not only which direction the vessels were traveling, but also gives us an approximate location for the vessel based upon the time the image was captured. And we see that this first track here is a good match. Its path follows the slick's path almost exactly. And you can see that if I turn this off, that boat is located there. Using this button here, filter slicks by this source, I can see if a vessel has been associated with other slicks detected by Cerulean. And I can click this button here to show the extent of those other slicks And then if I click on this one here, I see that Cerulean has detected another slick where this Panamanian cargo ship was responsible for the slick. Okay, so let's take a look at a few more examples. As was mentioned earlier, not all detections are going to actually show oil in these Sentinel-1 images. Sometimes we get what are called false positives, which are generally dark patches in the water that look like oil, but are actually something else. One such instance can be seen here. Now, in this case, the future we're seeing is probably weather-related as opposed to something caused by vessel or infrastructure. It shares similar characteristics to an oil slick, so it confuses the model. In this example, we see what we call a dark vessel. There will come a number of times where you'll encounter these dark vessels, meaning that they're not broadcasting AIS positions and can't be identified. So if I turn on these three tracks, they don't appear anywhere near the slick, so they're probably not our culprit. And unfortunately, we see this with a lot of slicks. In this example, we see a polluting vessel with no corresponding AIS. Okay, let's take a look at one more example. Here's a typical example of infrastructure pollution that we'll come across in Sentinel-1 imagery. The most obvious feature of an infrastructure slick is the stationary source point in the imagery over time. Another important feature to notice is that the slick will tend to be non-linear. So I'll turn that off here. Slicks coming from stationary sources will be influenced by the local wind and current conditions. So infrastructure slicks will present these wavy, wispy patterns. And when identifying infrastructure in the Cerulean platform, the detections will look a little bit different than what we've previously gone over. So if I turn this on, we see a transparent red circle here, as opposed to the track we're used to seeing with vessel detections. Also notice that each infrastructure point that we have in our data set will have this unique identifier here. And we can utilize this to check our data set to determine if this infrastructure point has been involved with other slicks in the past. And we see that here, if we click on the filter by slick source button, that this source has been corroborated to a few other slicks in the past as well. And that concludes our demo of the Cerulean UI.
Thank you so much, Brendan. To wrap up, I just want to mention that we are already starting to see some organizations getting into the data and finding interesting stories. From the AP to the BBC, we are eager to support and partner with groups that are trying to make a difference all around the world. Our database is open and available to all public users, and the machine learning model at the heart of the system is constantly being improved. We expect a substantial upgrade to roll out next quarter, and we plan to process the entire S1 archive at that time, so you'll have a much deeper understanding of historical trends as well. Finally, I want to mention that all of our data is accessible through an OGC compliant API. The relational databases include metadata details like the Sentinel-1 scene a prediction came from, or the machine learning confidence of any given prediction. As well, it also includes geographic data about which EEZs and MPAs are affected for analysis. And finally, geometry data about the extent of potential oil spills, which can be discovered in a browser as seen here, or downloaded in GeoJSON format. Thank you again for your time, and I hope you get a chance to try it out for yourself. Please feel free to take a picture of this slide for your future reference. Enjoy the rest of the conference.